Okay. So before I start, maybe let's make a brief survey so I don't waste your time and I spend, focus on what you don't know instead of what you do know. So who has already used Yellowstone in this room? Okay. And another supercomputer, maybe among just the ones that didn't use Yellowstone? Okay, so I guess most of them will know what it is, LSF, Slurm, or PBS, or something like that. Okay. And who is familiar with SSH, X tunneling, and BNC, and some at least? Who is fully familiar with the DRS syntax? Well, you give at least, ease some of that for me. And who is familiar with the module environments? Okay, so pretty diverse audience. So now that I know a little bit about you, let me tell you a little bit about me. So I am a software engineer in the user service section. And here's the website, which, besides from finding from these slides, which I think will be posted in the on this school website, you can just Google user support NCAR, and maybe not exactly that page, but one of our pages will pop up. And the best way to reach me is via an extra view ticket, by which you may reach me or one of my other coworkers. We take shifts, and there is always somebody, well, in business hours, let me say, there is always somebody to answer the phone and things like that. So that's the email, which is also mentioned on that website. So maybe, that's what that website looks like, and let me spend just a short time on it. Since this isn't my laptop, let's try to do what I said. NCAR user support and see what happens. Okay, that's the page I wanted. So there is lots of information here. Reverse scrolling. So there is all these boxes here. Each of these would, I think it's worth spending some time on. And this is more for you than for me. I would say half of the questions we get in our help desk are about something that's already written here. That doesn't bother me at all. But you spend the time to write that email and say, how do you do such and such, and then you wait for somebody to read it and to respond, and maybe your time was best spent finding the information here. You get the answer maybe faster this way. I think it's very well done. We have a documentation specialist that it's always very picky about what we tell him to write and say, well, this isn't clear. So I think it's very nice. Okay, so let's go back here. And mention a little more about the CMIP analysis platform, which I like to acronymize even more than it already is, and called CMIPAP. So the platform is made of various high-performance computing resources that we already have at NCAR. The most important parts are some high-performance disks that are mounted on our machines as a parallel file system that you will be able to access and use where you find the data. So maybe one of the other places where you can find this data, other than downloading them for either the official repository or for many of the mirrors, will be just to do the computation here, like I guess Dave Art was saying this morning. So we don't provide this platform as a download service. However, the data is there, and we provide file transfer functionalities from any disk that's mounted at NCAR, so you can certainly use it for that purpose, but that's not what we envision would be the most common usage. So that's one piece of the platform. So if we're on the disks, you couldn't do what instead we want you to do, which is computing and doing data analysis and visualization. And so you have a set of nodes. The ones that are more dedicated for that are 40. I mean, they're not exclusively dedicated to CMIP, but they are dedicated for this purpose are 48 nodes. Yellowstone in total has about 5,000. And if you have reasons to use any of the others, you certainly may. Maybe you have to ask, and we'll, I think, I mean, depending on your justification, how hard or easy it will be to get approved. But I think it will be relatively easy if you have a scientific case for that. But what the main part, the bulk of the analysis platform is 48 nodes. And they are often referred as the DAV nodes. And I'm calling them this way, and they will be called this way by some other people that you might talk about NCAR. And they are 16 nodes called Caldera that have a large amount of memory and 16 CPUs each and 2 GPUs. I didn't write a 16 GPU, but it's in our documentation. Then there are 16 nodes that have 1 terabyte of memory per node, and that's not a typo, so that's not the disk, that's a RAM. And they have a slightly different CPU, because when we bought it, that wasn't available for the latest and greatest CPU, so it's a little older CPU, but there are 40 of them instead of 16. So that kind of pays back about being a kind of older architecture, and only 1 GPU. And then we have 16 nodes called Pronghorn, which confusingly enough are reachable within the Caldera queue. And they are identical to Caldera other than not having the GPU. So if you need some work for the GPU, you want to use the Caldera node because maybe it has 2 GPUs and you want to use 2, or maybe you are okay with memory and want to use those. You have to make sure that you're not using Pronghorn. So then the next step will be a high-speed InfiniBand interconnect that all these nodes. So if you need to run multi-node jobs, if you know what that is, you can. And they have I mean, not the latest and greatest because Yellowstone is 3 years old now, but it's a fairly good IB interconnect, and certainly was state of the art when we bought it. And it also has a high-speed network that goes to the outside world. So usually, if you have any troubles, say, well, this data transfer, this thing is taking too long, that should be on your side or in something in between, not on our side, unless there is some problem. And we have a pretty good networking team that if you do encounter some problem, will help you with that. So enough of that. Everybody here should be already have an account, and maybe waiting for Jean-Francois to nod on this. So you already have something like this USB memory stick, which is not a stick. Actually, this is a keyboard. So this will look like to the operating system as a keyboard, but you don't tie. It has only 1 button. It doesn't have all the 104 usual keyboard buttons, because you push that single button and it will type a password for you, so you don't have to remember the password. Now, since that was maybe a little unsecure, if you lose it, somebody can push that button and get the full your password. There are 4 more characters in your password which should have been given to you as a sticky note or something with that, and we suggest that you don't keep them together, because if you lose them together, then whoever finds them can use them. But since this gets recorded and might be used by other people that don't have an account, let me say that if you don't have an account, you can request one for the very purpose of using the CMIPAP. And everybody who has an account, either for the CMIPAP or for any other reasons, can use this platform with their own allocation that they may already have associated with that account. Or if they can't or don't want to use that allocation, they can request a specific allocation. But if you need a data set that's not available, you do need to have a CMIPAP allocation. And if you don't have it, you have to request it. Excuse me. Now, if you aren't confused, I will confuse you. If you are confused, I will try to clear things up. So the account is your ability to log in into a machine, in this particular case, Yellowstone. And that's basically a tie. If you have a YubiKey, you have an account, because that will allow you, well, unless it's been disabled for some reason, but that will allow you to log in into the machine, and so you have that account. Now, the DAF nodes that I was mentioning before are part of the Yellowstone supercomputer, and you log in into Yellowstone. You don't directly log into any of these DAF nodes. So the account doesn't distinguish between Yellowstone or Geyser, Caldera, or whatever. The allocation, on the other hand, which sometimes is also called project number, is enough. I mean, it's called number because it used to be a number, but now it's alphanumeric, so it's not a number. But it's kind of a string that gives you the ability to submit and run jobs remotely on these other nodes that are not the login node. And so the allocation does make a difference between the Yellowstone nodes and the DAF nodes. And usually it's not something exclusive to you, like the YubiKey. That's your account, and whatever you do with that, if you install some software, spyware or whatever, our security team will come after you and you are responsible. Whereas the allocation is shared usually between a group of people, a research team, or could be even a larger group. And depending how you burn it, that means that so the whole team is kind of collectively responsible for using it, and you can run it to do whatever your research is. Is there any question about this? Okay, since I see most of you have a laptop, maybe you can try to log in now if you haven't already in the past. And the requirement to do that would be to use SSH. So if you have a Mac or Linux, you just have that already installed. Otherwise, if you're running Windows, you should use one of the SSH client like one of these. I know nothing about that since I don't use Windows since the late 90s. Now, this will allow only the command line login. So if you want to do anything with GUIs, and I guess you will, you also need either or both an X server and a VNC client. So again, for Linux, you have it included, and that's what I do actually on my machine. Now I'm not sure if this will work on this laptop since it's not mine. But on both Windows and Mac, you will need an X server. So in some of these software are mentioned here. For VNC, the only software we support is this Turbo VNC, but I heard that some, but not all other VNC client do work. So let's see if we can do this. I can do this with you. Let's see, can I have a shell here somewhere? How do I get the shell in the Mac? This one? Yeah, I know nothing about Mac, other than they have an Apple on the back. Oh, that was it.
Oh, yeah, thank you.
Yeah, console maybe, or terminal, yeah. Perfect, thank you. So you type SSH, your username, in my case is Vento. And well, before this, let me do also the -X for trying to do an X tunneling. yellowstone.ucar.edu. So this laptop never connected to Yellowstone. It doesn't trust it, but I do. And so it asks for this token response. So is your address space without the UCAR email address, not any other address that you might have. So that should have been given to you with a YubiKey, I guess.
Oh, well, you need to.
Well, I mean, we also have the lab where we'll do this, I guess, also. I don't know. You will, during the lab, people will be logging into Yellowstone too, right? So, you know. So what I did, I pushed that button in the YubiKey, and so I am in the Yellowstone. I have this colored prompt because I like it. Now, if this Mac has X window running, I should be able to do this and see the clock, which this doesn't. I'm not going to debug to install this X server now, but you might if I bore you with my talk. So let's continue the rest of the talk, and feel free to try to move forward with that. And I don't know if you want to maybe help some people. I don't know if you want to do this now or you prefer to do that everything in the lab. So maybe everybody knows that has a problem can ask this as a first question. So up to you how do you want to do it. So this is what I just showed. Let's talk about instead of the available data sets that we have on the platform. So data sets are continuously added. Continuously added to the platform. And so you might want to check if what you need is already there. And you can request it if it's not. So let me show you this part of the website, which I think it's very useful. So there is this CMIP analysis platform link here, which gives a general description what it is and what you can do. And then there is this link of data set available either from here or from here, which goes to this page. And so it says, for example, that there is this NCAR CSM model. If you click on the plus, it has various experiments with different frequencies and realm available. Now, since these are NCAR data sets, we are, I don't know if we are required by the CMIP agreements, or anyway, we want to keep them, so we won't remove them. And these are data set we received a request to install, and so we have a pending removal for the date specified. That doesn't mean that certainly they will be removed at that date, but if size and available space on disk become an issue, they might. And we will contact whoever requested that particular data set, but maybe you are using that and you didn't tell us, so you might not get contacted. In addition, we also monitor what happens to these data sets, so we know how frequently they are used. So it's more likely that if some data set is not used, it could be removed, even though maybe there is another one that has an early removal pending. So all of this we are learning, as says this bullet. And let's see, well, I mean, I can say more about this we are learning part later. maybe let me just say something about the DRS syntax that we are using right now. Now on the website, as you can see in this screenshot, there is a link, probably that's the same document that has been shown before, about this DRS, but I think it's useful to quickly describe. So once logged into the platform, you can see several file systems, and there is one particular directory that's, that Glade P is basically a file system. So there is this CMIP directory there, which contains, for now, only the CMIP 5 data. I will contain the CMIP 6 when it will become available. And it is organized like the website table that I just showed, into a hierarchy of activity, product, institute, model, experiment, frequency, and realm. And now these are the same things that are specified on the website. Now further down the path, these are not specified into the website. We don't get to the website in so many details, but the directory hierarchy goes down that deep. So there is the MIP table. After the realm, there is the MIP table, ensemble member, version number, and variable name. And the previous talk already showed some of this. Was there a question? Okay. So maybe just to show that I'm not lying, I can do an ls in that directory and see that it exists and contains that data. So glade p CMIP, I don't misspell it, there is just CMIP 5, and then contains, let's forget about ATH for now, so output 1. For example, it contains other stuff. So let's go into the next slide and then we'll be back to this one. So activity is basically CMIP 5, and there will be a CMIP 6 activity later on, as I said. Now the product are basically output 1 and output 2. There is also a possible unsolicited product, but I don't think there is any data really there permanently. And then institute, for example, it could be NCAR, but it could be many of the existing institutes. And then the model, for example, for model will be the CCSM4, which is a previous version of CESM. For experiment, of course, this uses different, doesn't use the dot, for example, for RCP 8.5, it just called it RCP 85. Then for the frequency, for example, it could be monthly, or it could be daily, or 6 hours, or whatever. Realm, this went to the next line for some reason, but that's Atmos, it's supposed to be on the same line as here. And so these are the part of the hierarchy elements that are also specified in the website. And then going further down, there is this MIP table, which in this case would be atmospheric monthly, and then ensemble member, already just explained. Then we have this version number. Now it is common. Well, I don't know how common, but it is possible that some data set got some, they found some mistake and they thought, well, that's worth releasing another version of this data set and, give it an official version so that we know which version you're using. So you're using the one which this problem has been fixed or not. So there is a version number. And then, for example, this variable name in this will be a precipitation. So let's see. Sure, question. For what you should use? I would say yes, unless you want to compare, some results from some other paper that say, well, I used this previous version. It might be you want to use the exact same version of that paper to prove something about that. But I would say, you should always use that. And in fact, many of the mirror sources don't even provide this. They just provided, hopefully the latest, but just one version. Some don't even mention what it is. So the question was different ensemble members of the same data have different version numbers, and if this is a problem or is this expected? I would say that's expected, but I am not the one making these versions. So maybe why don't you use the mic? So.
Yeah, the versioning isn't that well. Well, it isn't uniformly followed, but the idea was they were supposed to place a date as a version number reflecting when they published the data. So if you publish one realization a month ago, it's going to have a different version number than this.
Still the same model.
Same model, and if it's the latest version for that realization, then that's the one you should use.
Any other question? Okay, just to go ahead with this and showing that the data is there. So if I go, let's see if I can make this. So NCAR, NCAR has only CCSM4 data in CMIP 5. So if you go into there, then there are different things. So let's see, for example, this just use the same one that I used in the slides. Then there are different things. There are the fixed frequency, monthly, daily, 6 or 3 hours. So here I use monthly. And then you have the Atmos. And you have this Amon table. And then the different sample members. So that's first. And here are the various versions. Now, if you do with a -L, this will show that the latest version actually is just a link. That's what this arrow means to this particular version, which happens to be this one. Then if you go there, either with latest or with that, you go here and you have the different variables. So I took precipitation as an example. And how you can see here, these actually files are symbolic links to whatever is into the files part in here. So there is a files directory that actually contains the files. So these are just kind of directories to this link management. So I guess if you are looking for a particular data, I mean, if you are logged into the Yellowstone or CMIPAP anyway, you could do as I was doing there, but otherwise I would suggest that instead you go to this website and you look for what you are thinking to explore and see if that data is there. Now, going back to what I was saying, this is a kind of a work in progress. And I mean, with CMIP 6, probably if you have a beefy machine, you can do most of the work on your own, and maybe you say, well, I don't need the CMIPAP, so why taking the hassle of using it? But with CMIP 6, the data volume will be certainly prohibitive to do that. So we want to provide this service, and we are asking your feedback, to is this process working? So, maybe with minimal effort, well, maybe not minimal, but with some effort, we could provide all the data of CMIP 5 and be already there. And, you wouldn't need to do this process of going there and see what is available and what's not and requesting it. But as an exercise to get ready for CMIP 6, there is no way that we can provide all the data in CMIP 6 available for anybody. So we will just provide a subset, and so here we are kind of trying to make experience on how that process will work for both you to request and for us to manage the requests in a timely manner, and how to lay the data on disk. And in fact, that leads to another possible convention that I don't know how you feel about that, but many, well, not many, but some users, some early users that we have had so far say, well, this doesn't help me because maybe I don't care about having to request, all the data from CSM4. Maybe I just care about precipitation, or maybe I just care about surface temperature, and instead I want that for all the models. So instead of having this DRS syntax, which was put in place as part of the process to make CMIP 6 easy for the institutions, we kind of put this on upside down and say, well, instead of being the model first, let's make the variable first, because maybe that's what you as a scientist want to do. So we are considering using the what I call the ETH naming conventions, which instead of having these CMOR files into the directory like the one I just showed here, we would put this on the other, on the reverse. So you still have the CMIP 5, and what ETH does is puts the experiment and the MIP table first. It's not really the variable first, but the variable comes right after that. And then there are all the models. There is no institution. There is the ensemble member. And actually, there is no version. I think if we go through that, we'll make the version number still available, because I think it's a useful thing to have. Maybe we can decide to provide only whatever is latest at the time of download, but specifying which version it is explicitly, unless us leaving that unknown. I mean, maybe it's known, it's somewhere, but you have to dig it. Instead, it's not part of the syntax itself. So that's something that we are considering, and we'll certainly welcome your feedback on that, as well on all the process that I was mentioning here, which actually didn't show, but let me show it now. So, of requesting a data set. So here, instead of having these organized this way, that the first thing you say is NCAR. So say that you want to do a temperature, surface temperature study. Here, you have to go in each one of these models and say, well, do I have the temperature for NCAR, you have everything. So maybe you don't even waste your time on these. But we have the surface temperature on each one of these models, and there are a bunch of them. Instead, if temperature comes first, or maybe not really first, but right after the experiment, you would be faster to find. And then, supposing that you have something that it's not there, you can use this form, which is also linked from here, request MIP dataset. And you will have to provide your name, your institution, your email, your username, and that's the project, the allocation project number that I said before. Oops, what did I guess try to find it. Yes, instead of going up and down. I don't use my smartphone. So then you have a starting and end date. Again, this helps us planning the allocatable disk space. And then here you specify the realm. Currently you specify the model first, so maybe you want to specify all of them. And here you don't specify the variable at all. You do specify the experiment, but not a variable. So this, if you say, well, I want all models and all variables, that quickly becomes non-manageable. I mean, maybe still doable for CMIP 5, but not certainly for 6. So if you have any comment about that, maybe send that email to CISO help, so that we can do something that works for everybody, not just for a few vocal ones. Okay, so if there isn't any other question about that, we kind of switch gear and go more into the action. Okay. So once you logged into Yellowstone, the default shell is TC shell, which seems to be a favorite one by the NCAR people. But I know many people like Bash instead, and you can switch to Bash if you want from SAM. SAM is a website that you can find in our documentation. I won't show that for the sake of speed, try to be on time. Then we have on the machine a long list of software that's available. And in this list, some software have the same name either because they do, but they are different things. But some actually are different things. Some are the same thing, are just different versions. We try to maintain every possible, not every possible version that exists, but every possible version that has been requested at one time. Instead of just removing and putting a new one, we put the new one without removing the old one. And we do this because sometimes, and we have had troubles with this in practice, sometimes the new version fixes one problem but maybe causes another one. So maybe you want the latest version, but he wants the old one because what he's doing, your version breaks. So to manage all this, you do Python, for example, or MATLAB, you want something to happen that's different for you than for him, so we use environment modules. So if you know what I'm talking about, you already know everything. If you don't, I will show quickly a demo about that, and it's pretty easy. So that's my shell as before. Up. So if I do module available, it will show me a fairly long list of software that's available. So on top here, there are some compilers. Here, there are some software that are not dependent on the compiler. And on the bottom, there are yet other software, usually libraries, that do depend on the compiler. So another command is module list. So let me do this. So this shows, let me do that to the top, maybe that's easier to see. You can shorten module list in ML. So that shows, well, I have the Intel compiler version 12 and NetCDF version 4.3, and I don't have Python. So if I do, for example, ifort, I don't know if you're showing anything with needs to be compiled. But yeah, just because I can do this, let me do version. It shows that version 12.1.5. If I can do module load and say that I want Intel, maybe I want Intel 16.0.1. Of course, when I shorten version, I don't have to do load. I just do ML. And then if I do ifort again, let's say, well, that's a different version. Now I don't have any Python, but actually there is a Python that's installed by IBM. It's pretty old, it's 2.6. So I can do module load to show the long version of the command, Python. And this will make available 2.7. So the commands you need to know are list, available, load, maybe swap. So swap basically, well, another one that I didn't say is remove. So if I say that I don't want to use this module list to show that I have Python, but I don't want to use it anymore, so I can do module rm to remove Python. And maybe I want to remove Intel and load GCC. Instead of doing remove Intel and load GCC, I can do module swap Intel with GNU. I would say GNU because it could be also G-Fortran. Okay, so enough of modules, unless there is any question. And let's go back to the presentation. So, running jobs. Now, question. So the question is how many modules you can load. And the answer is as many as you want. And actually, there is documentation on our website about that. I'm not showing that for the sake of time. But you can save your own session. Say that when you do a particular kind of job, you load 20 modules, and you want to save that with a particular name. You can save that into a file and say, call module save, blah, blah. And then you do another kind of study. You want different set of modules. You can save that with a different name. And so you can do that kind of stuff. And there is no limit. Any other question? Okay. So maybe, I mean, if you have used any shared resources in other places or NCAR, you know that once you log in, you are not having the full supercomputer yet at your fingertips. What you have is one of the 6 login nodes that are usually shared with hundreds of users, unless it's Thanksgiving, maybe you have a little less. But it's amazing, even a night of odd times, how many people are there doing stuff. So you might not run anything heavy on that node. And if you do, we have some watchdog processes that will kill your section, sometimes a little too aggressively. But what you're doing will impact negatively other users and the whole health of the cluster itself. So that's why we lean toward being more aggressive. So if you need to run anything that it's relatively heavy, you should use the Yellowstone nodes or the DAV nodes. So for doing so, you need to use the LSF queuing system, particularly the bsub command. And a job that you run, it could be either batch or interactive. So you can still have another node at your fingertips if what you want is kind of interactively doing things. Now compiling, you say you won't do anything for this tutorial, but that's pity because otherwise we could go in the hallway and play instead, claiming that we were working. Now, the easier way to submit a job is if you want an interactive job on the DAV resources, you can run one of these scripts: Go Geyser, Go Caldera, exec guys, and exec Caldera. And basically, the difference, besides the name, I don't like the names. I think they are kind of confusing and they don't show the difference. And they are this way for historic and backward compatibility reasons. But the main difference is one allows you to specify the location you want to use and the other doesn't. So I suggest that depending on your particular case, there are some people, probably Jean-Francois is one of that have several locations. And so you always want to specify which one to use for one particular job. And so it will maybe use always the Go Geyser, Go Caldera, whereas maybe someone else that has only the CMIPAP allocation could use the other one that instead of always having to remember that number. And so you just pick yours and then you say, well, what I care about is this or that. And in both cases, you might need to do a source of your dot file if you want to keep exact same environment as before. So let me show you an example of this. So if I do Go Geyser, again, I have to specify the project. So let me do exec Geyser instead. So exec GY. So say, well, okay, this one tells you what it is doing, and it is submitting something like this, which we will show in a minute what it means. But that says it's using your default project, which is this one. And now you're in a queue, and so you're waiting for this job to start. And here it is. So it started. So I can do ls. I can do whatever I was doing before. Like you can see, I lost my nice colored prompt. So if I wanted that back, I can source my bash profile. And depending on various circumstances that I'm not describing, you might or might not lose it. So, but it's easy, either a bash profile or whatever your TC shell dot file is. And actually, it's not totally lost. So if I do module list, you see that I still keep this GNU thing that I swapped up here. So that's not a total loss of your environment while you do that. So this is a way to, now I'm on Geyser. I have this, I requested only one processor. I mentioned before that Geyser has 40, so it still is a shared resource, but it's shared maybe among 40 people at most instead of hundreds. So I have basically one processor, so mine. Questions about this? Okay. Now, you might need to run something that's more than one processor or that needs something more. So how that command showed into the log, what it is doing basically is running this command, and you can run this command yourself and maybe change things and have more flexibility in what you might be doing. So, for example, let me explain these most important arguments. The IS is for interactive job. So if you run something that's just a script that you say, well, I want to submit this one and I go to bed and I'll see tomorrow what the result is, you don't use it because you have a program into the file that you say, well, run this file. And so you do not use that in that case. Otherwise, if you're there at the keyboard, I want the prompt back or I want a GUI back and I will be doing something with that, then you do have to use the IS. Then you have this queue option, which is the queue name. The queue names, I guess, most commonly used for a CMIPAP will be Geyser. You might need to use Caldera with a caveat that you might get a Prongo node. I guess some of the exercise, particularly Dorit ones, here will be on Yellowstone just because everybody is running at the same time and they want the results as fast as possible. So Yellowstone has 5,000 nodes, so it's more likely to find, I don't know how many people you are, 20, 40 or whatever. So it's more likely to find that number of nodes immediately available among 5,000 than among 48. Probably won't be that bad, but still, for a tutorial, that would be more nice. But unless you explicitly ask for strong reasons, you wouldn't be able, as a CMIP allocation, to use that on Yellowstone. Then you have this N, which is the number of tasks, which is misspelled here. So 1, which is what it does if you just call exec, or it will be for serial job. But you can ask for more CPUs. For example, a common number will be 16 or 32 if you want a full node for you. Then you have to specify the project number, and there is no shortcut here. You do have to specify it. And then you specify the walk clock limit. And the reason why we asked that is that we have a kind of a knapsack problem here, so that you have one job, he has a job, he has a job, and she has a job. And the queuing system try to maximize the utilization of the system and minimize the waiting queue for everybody. So if you say, well, I need a job, but I don't know how long it is, then the queuing system doesn't know if you get better priority than him, or maybe you can run after so many minutes that you have done. So maybe it's a fair waiting queue for him to wait for your job to complete. So you do have to specify this, otherwise the job isn't accepted. Now, in this case, the command you want to run in this example is just the shell, because that's an interactive job that I was showing that, I want the prompt back, I want to do ls and stuff, and so you can have shell, but you can have basically any executable you need to run. And so this is one way to present this data, but you can present exactly the same information, and I like this better, into a file, so that it stays documented in a place instead of just being in your memory. Oh, what I typed when I write this thing? You write a file that will look like this, so exactly the same arguments as before, but while before you had bsub blah blah blah, and for example one of these blah was the dash p with a project number. Now that dash p becomes one line of this file prefixed with a bsub comment like directive, and then you have the project number here. And so the same for the walk clock limit, for n, and so on, everything that we had here. And then something you can't read because this has a different form factor than my laptop. See if I can. Oh, I can't because I am not logged in. But anyway, there is this MPI run.lsf thing at the bottom. And if you didn't run a parallel job, that is how you do it. And I think Dorit will show some of this, or Doug, maybe one of this. Is it tomorrow? So I could run some jobs, but we are getting short on time, so I won't. Basically, it's very similar. My example were very similar to the other ones that I did, but I want to show you that in the website, you can go here. If I remember how to scroll, go into Yellowstone, using computing resources and running jobs. And you have all the documentation of what I just said besides my slides. Explained in the details, maybe even too much detail, more detail as you want to know. And you also have information about the queues, which you might or might not care about, since you probably just will use a Geyser queue or Yellowstone queue for that exercise. So I'm not sure if you plan to use anything with VNC, and I don't know if you know what a VNC is, but let me just mention that we have that. So the thing that didn't work, with when I logged in, let me show you. When I logged in, I typed X clock here. Let me get out of Geyser. X clock. And this gives me an error because this laptop doesn't have the X server, but otherwise you should have seen a clock like this popping out. That was just an example. I mean, you can run any GUI program, MATLAB, for example. But that gets, you just get a window containing that particular program. Now, that's one way to do it. Another way to do it is just getting desktop sharing. So you have an application, so a single window on your laptop that will contain the whole desktop of Yellowstone or Caldera or whatever node you're running. And you can run that as a full machine. Now, that requires TurboVNC installation on your machine, and it requires the setup of an SSH tunnel. So it's a little, it requires a little bit of configuration. It's not tricky, but you need to do something more than just firing it. And I'll just show this real quick. So you do VNC server submit -p with a project number. That is mine. You will have to use yours. And what this does is submits a job and say, well, I've submitted this particular job with these options. So you didn't specify any options. So by default, I'm submitting 4 hours of walk clock limit and this project, and I'm calling this job this way. And so you wait for the job to start, and now the job started. Now the server needs to start on that particular job, so you still have to wait a little bit. And when that starts, it will give you some additional information that you will need to connect to that server so that you can show, you can look at that desktop, remote desktop from your own. So, and yet another feature of this VNC is that, say that you are doing some work and then you need to leave and go home, that work stays there until the 4 hours are elapsed. So maybe I start doing some work here now, then I shut down this laptop, I go home, maybe I'm fast enough that I will be there before the end of the 4 hours, and I can keep up with that job. Now the server is taking surprisingly long to start. Usually it's much faster. But yeah, so let's not wait for that. So, so after you have done that, you will need to do an SSH tunnel, which is explained also here in the documentation, but it's explained in the, when the server starts saying, well, type such and such on your desk, on your local client. Now, the important part is that the type such and such won't be in this shell here, but you have to open another one. So you have to open another terminal. I don't know how you do this here. With a new window here, and in this new window, you have to cut and paste whatever this thing here will tell you to. So that would be something SSH with some options to make the tunnel. I have only another couple of slides, so let me go quickly through that. So the list of available software is very long, as you can see. I don't want you to read this, especially not the one on the right. And I kind of highlighted some that I think will be the most interesting to you, but certainly there is more. And if you have something that you need that's not there, we are very happy to install it, especially if there is no license to pay. If there is, probably we'll ask you to pay, and we could still bring it. But we do have some licensed software that's already paid for us, by us. For example, MATLAB, I think it's a very popular for this community. And the last one, which maybe we can do at the lab, so we end on time, is this ipython notebook. That's the version 2, so that's before Jupyter. Also requires a tunnel like BNC server, which maybe we can explore there if anybody wants to. So I have.